Good day, I'm Dr. T and welcome to my office. So today I would like to talk about electricity. Electricity is the transfer of energy by the movement of charge. So if you're familiar with an atom, atoms are made up of protons, electrons, and neutrons. The neutrons aren't going to be playing much of a tale in this particular story, but the protons and electrons are. Those two subatomic particles are charged. They have opposite charges. Electrons are negative, protons are positive. They attract towards each other, but they repel individuals of the same kind. So, negative charges repel each other, positive charges repel each other, but opposites attract. Yay! Okay. We're going to use these to our advantage. If you have an atom that's got the same number of protons and electrons and it moves around, nothing interesting happens. However, if you move just the electrons or you move atoms that have an unbalance, they have more or less electrons than protons, what we call ions, then we can move energy with these because these are charged particles. So now we can take our energy source and we can use energy to get these things to move, and as they move, they're going to help us transfer energy around wherever we want it to go. And that's incredibly useful. That allows us to have a big old coal fire plant far away, transfer the energy to your house, and do things useful with it. Or ideally, maybe some solar cells far away and, you know, not have a ton of burning coal. But moving on. When we're looking at the charge, we're actually looking at typically two properties for it. There's going to be a couple others that come into play. The first is going to be current. That's how much charge is traveling through your circuit. So this is going to be how many electrons are traveling through your wires, or how many ions are traveling through your liquid. Things that allow charge to flow through, those are called conductors. Typically we're thinking things like metal that allows electrons to flow freely, or graphite, oddly enough, allows electrons to flow quite freely. Or alternatively, you could have solutions that contain ions, what we call electrolytes. Conversely, things that don't allow electrons to flow freely, those we call insulators. Okay, so the electrons and or ions are traveling nicely. We're going to run into a quick problem, though, if we're simply going from point A to point B. As the electrons travel, they're going to start clumping up at the other end. They don't just go away. So if they start clumping up at the other end, that's going to become negatively charged. It's going to be repelling new electrons, so it's going to make it harder for those new electrons to go towards it. Additionally, they're going to be depleted on the positive end, so it's going to become more and more positive, and thus trying to pull electrons back. You can have an electric current in this situation, but only for a very brief period of time, and what you have created is a capacitor. These are, by the way, quite useful as ways of storing energy, but you're not able to move them. The way you move electric current is by allowing it to go in a circle. Thus, we call systems that transfer electric current circuits, because they're circles. This way, the electrons can go out one end and effectively do a lap. Now, in this case, a couple of caveats. For starters, the individual electrons probably aren't going to do the whole lap anytime soon. They actually move quite slowly. It's kind of like standing in that giant long line at the post office, and then one person moves forward, and then you move forward, and then you move forward. And while the line moves, you're still moving very, very slowly. It's just everyone taking a step forward. Second, the electrons don't have to always be going in the same direction. For the electric current to travel, while energy is being moved, the electrons do need to move in the same direction, but that doesn't mean they can take a brief pause and all step backwards, and electric current can flow backwards. Hey, that works. If they're all going in the same direction constantly, that's called direct current, or DC. If they're all going backwards and then forwards and then backwards again, that's called AC. Both types of currents have their advantages and disadvantages, which I'll discuss in later videos. Now, the amount of current, hey, that is current. That's how much charge is moving. The units for that is typically going to be amps. Now, the amount of energy traveled by that amount of charge moving can vary. You know, how hard is it being pushed/pulled on? That is what we call voltage, and the unit is volts, because we're original in naming units. As you might guess, the amount of energy per unit of charge and the amount of charge per time would give me the amount of energy per time, which is what we call power. And power for electrical systems is typically measured in watts. So multiply voltage times current, which would be in amps, and you get power, which will be in watts. Yay! Now when looking at my circuit, I've got a couple of other things to consider. With current, the greater the current, typically I get more waste energy. That waste energy goes off in the form of heat, and that can give me a couple of problems. One, for some systems, the warmer they get, the more resistive they get. This is the amount of resistance they take to the flow of charge. Basically, the amount of energy they're siphoning off. More resistance typically results in more heat, and more heat could result for things melting. So I have a few things to keep in mind here. One, I want to make sure my wire is big enough, because typically bigger wires have a little bit less resistance, and, well, they're a little harder to melt. Second, when I'm looking at the wires or the other things in my circuit, I want to know how much power I'm going to be moving, how much voltage I'm going to be utilizing, and thus I'll be thinking about terms of the amount of current times the amount of resistance that what I have creates, and it's going to involve how much voltage is going to be being utilized, how much energy per charge is being siphoned off, which gives me a good description of power. Now, if you're thinking, but I don't want waste energy, I don't want my system heating up, what can I do to stop it? Well, I could use a higher voltage. If I use a higher voltage, then I'm going to have less current because those two are inversely linked. So with a higher voltage, yay, everything goes great. However, there is a trade-off with higher voltage, and that's the amount of energy per charge, and the more you push on them, the more they might go do something crazy. Typically, your electric circuits are going to be wrapped in a material that does not want to conduct electricity, what we call an insulator, because, you want to control where the electricity goes, not just splatter it everywhere. And the higher the voltage, the more insulator you're going to need. Additionally, if you get a situation where, you accidentally touch the thing, the more voltage, the more likely it's going to start pumping a ton of current through you. You don't want either one. The current's what you have to worry about, but higher voltage allows for a higher amount of current, pretty straightforward. So you do have some safety concerns with higher voltage as well. For that reason, when setting up electric circuits, there's always a balancing act. You want enough voltage to get things to go nice and smoothly, but you don't want so much that it creates a problem. And for this reason, we will see voltage being modified depending on what part of the circuit you happen to be on. So if you've got a power plant, the voltage typically gets raised to really, really high. You go to high voltage lines. And then before you get your house, the voltage is dropped to something a little bit more reasonable, just a little bit less efficient. But then again, your house isn't that big compared to the miles and miles of high voltage power line that's connecting your city to the power plant. So a couple of things to think of when we talk about electricity, and I will talk more about those and what we're doing with it in later videos. So talk to you later and have a wonderful day.